Okay, hey, good day today. Now a quick video. We're going to talk about our sequences, and notice I don't have commas in here because I'm adding up all my terms. Here's sequence A. Here's my first term, second term, but we're going to add things up because we're going to take the sum of all our terms in the sequence, okay? And this is represented by this Greek letter sigma, which is called summation notation, or sometimes sigma notation. We've got a value on the bottom at the top, and this tells us where we're going to start. And this is sequence A with the subscript K, and K will start at 1 and go all the way up to N. Okay? So that's kind of the way we write things. If we leave it open to, we're going to, we don't specify, we're going to sum up the first 5 terms or 10 terms, we just put N. The way we write is, we're not going to say N equals 1 up to N. We'll start off with a different letter, and don't worry about this so much. It's kind of semantics and stuff, but I can start out with I, K, J, or whatever, and say, okay, we're going to start off with K equals 1, but we'll go up to the first N terms. N can represent anything. When we do that, our subscript will match this K and this K, okay? And we're going to go up, okay? Alright, so we're going to plug in 1, 2, 3, all the way up into N, alright? So this is summation notation, and here obviously we're going to sum up the first term, the second, to the third, dot, 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 all the way up to, how high are we going? To N. We're going to add all the way up to the nth term. Okay, again, I'm going to do summation. This is sigma notation. I'm going to take the sum, and here is my formula of the general formula for my sequence, okay? Okay, and we know how to do this. We plug in a 1 anywhere there's a K. So we're not so again, let me give you an example here. Here's an example of where I start out using K equals 1, and we're going up to 9. So we're summing up the first 9 terms, okay? Here's an example of where I start off with K and it equals 1, and we're going up to the first N term, all the way up to N, and here notice I've got N minus 1. So there's just some randomness to this. Don't worry about it, but here's where we're going to start as far as starting our terms, and here's how many we're going to sum up. We're going to sum up 9 terms here. Alright, let's get back to this. Okay, so here's something we're familiar with. We plug in a 1 anywhere there's a K or an N. In this case we're using a K, and we're going to this is what we did today. Okay, K over K plus 1. So for the first term I plug in a 1 and 1 plus 1. The second term I plug in a 2 over 2 plus 1, 3 over 3 plus 1, all the way up to what? How many terms? To the nth term, which would be N over N plus 1, okay? N could be 20, all right? And that would be 20 over 21, okay? But instead of commas, we're summing everything up. We're adding all the terms, and that's what we want to do, okay? All right, from here, we're starting out at 0, okay? Okay, when it's K equals 0 up to N and that's kind of looks like a typo to me, because what did we plug in here? What was our first term we plugged in? Okay, there should be a typo there, because we can cover this later, but this should be K equals 1 to N, okay? Alright, and I'll talk a little more later on about variations on that. But there's a typo right there. That should be K equals 1 to N, because what's the first? Here's our formula, K squared minus 1. What do we plug in first for our first term? We plug in a 1. What do we plug in for our second term? A 2. 3, all the way up to N for the nth term, okay? So this would be 0. This would be 2 squared is 4. This would be a 3. This would be 8, and so on. Alright? But we're adding these terms and summing them up, okay? Here, express each sum, so we're kind of going backwards here. Notice I've got 1 squared, 2 squared, 3 squared, all the way to 9 squared. So I could write this in summation notation as, okay, where do I start? I'm starting K equals 1, and I'm going sum how many terms? Up to the first 9 terms. If that said 15, it'd be all the way up to 15 squared. But okay, and what are we doing? We're squaring. So k equals 1. I'm going to sum the first 9 terms from 1 to 9 of k squared. 1 squared, 2 squared, 3 squared, and so on. Okay? Again, this is a sequence, but don't get thrown off by the plus. This is my first term, second term, third term, ninth term. First term, second, third, fourth, all the way up to the nth term. Okay? This is a geometric sequence. It's basically what's happening. Forget the plus signs. What's happening between terms? From 1, I multiply that by 1/2, and I get 1/2. 1/2 times 1/2 is 1/4. 1/4 times 1/2 is 1/8, and so on. So notice this is what's going to be called a geometric sequence. That's in a couple days. But the difference between these terms is a factor. We call it a common ratio. All right. We're starting off what? The first term I plug in a 1. So notice 1 over 2 to the n minus 1 power here for your denominator. I plug in a 1 there. 1 minus 1 is 0. 2 to the 0 power is 1, and 1 over 1 is 1. Then I plug in a 2 for my second term. 2 minus 1 is 1. That's 1/2 times 1/2 is 1/4, and so on. And there's our formula for the nth term. Okay, if I wanted to sum up the first 4 terms, it would be k equals 1, and up here would be a 4, and this would be at 1 plus 1/2 plus 1/4 plus 1/8, and we would add that up. Okay, all right. Finding the sum of a sequence. Here's some rules. All right. A is a sequence and B sub n is a sequence, and there are 2 sequences. C is a real number, which is going to be a constant. C stands for a constant, like 3. Okay, 3 doesn't change. It's always 3. All right. All right. If you're summing up the first n terms, here's starting at k all the way up to n of this constant times the sequence. This is a constant times these first the sequence A sub k. All right, notice here's my term. It's basically C times, if K is 1, it's C times A sub 1. K is 2, it's C times A sub 2, and so on. All the way up to C times A sub n. Notice in all these terms, A sub 1, A sub 2, what? They all have a common factor of C. Notice how C comes out, and we factor C out. Notice I've got C times everything in the parentheses, A1 plus A2 and so on. So we can basically, this rule here, take the C out and put it in front of the summation symbol. Okay, so basically what they're saying is, hey, sum up all your terms, A1 plus A2 plus A3, and then when you're done summing them up, you can multiply all that by C, because that's what you're doing here. Okay? Add up all your terms and then multiply them by the constant. All right. This one's pretty basic. I'm going to sum up the first, let's say, n terms. That could be 10. Let's just make it 10. From k equals to 10, k equals 1 to 10, of sequence A and sequence B. That's the same thing as taking the sum of A, sequence A, and then adding to the sum of sequence B. No different. We can do it all together or separate it and sum up each sequence separately. Same thing with subtraction. Okay, I've got these 2 different sequences. I can, this sigma notation of sequence A minus sequence B, we can do that first and then sum it up, or we can do what? We can sum up sequence A, the first n terms, add them all together, and then subtract. So notice I can apply the sigma to each of these, sum up sequence A, and then subtract sequence B. This is the same thing, okay? So you can separate it. And finally, this is kind of, a little confusing. Basically, notice J is on the number line between 0 and n. All right? Notice, I'm not going to start off at like k equals 1. K equals some number j plus 1, and we're going to take that term and sum up all the way up to n. So we'll start off with j plus 1, j plus 2, j plus 3, and these are all a sub j plus 1, a sub j plus 2, all the way up to a sub n. Okay? That's the same thing as, and notice we're taking sequence A and starting from 1 all the way up to n, and then subtracting out the sum of from 1 up to j. That wasn't, sorry about that. Alright, sorry, my computer kind of went out of me. Alright. So anyway, basically, where were we? Okay. I'm starting at like an intermediate value like from 5 to 10. That's the same thing as starting from 1 to 10 and subtracting out 1 to 4. Okay? Alright, that's basically what we're doing here. Don't worry too much about this. We'll explain more about this tomorrow, okay? Alright? But we're starting out not from the beginning, but at like j plus 1 all the way to n. So that's the same thing as doing the sum of the sequence from 1 to n and then subtracting out 1 to j. Because where did we start? J plus 1, okay? Alright. Formulas, these are some things we're going to, don't worry about this, but if you just are summing up terms like k, 1, 2, 3, this is something you can do on your own. If I'm going to sum up the first, let's say n is 20, the first 20 terms of just k, like 1 plus 2 plus 3, just some number k. I can do 20 times 20 plus 1 divided by 2, and that will be, this formula works manually. We'll have a calculator to do this, okay? But if you're just adding up 1, 2, 3, 4, this is your formula, n times n plus 1. So the first 10 terms from 1 to 10 would be 10 times 10 plus 1 over 2, okay? So that would be 55. If it's k squared, we have a different formula. Let's say I want the first 10 terms again. It'd be 10 times 10 plus 1 times 2 10 times 10 plus 1 divided by 6. And if it's cubed, I want to sum up the first so many terms. Let's say 5. This is 5 times 5 plus 1 divided by 2 and all that squared. These formulas work if you manually want to sum things up. We've got an operation, the calculator, that does this, okay? Alright, and we've got some more examples here. Alright, one thing, we've kind of talked about those formulas for what? The summing up just terms like k, where it's 1, 2, 3, 4. The constant times our terms. Here's the k cubed, and where did my k squared go? Here it is. Okay, here we go. Okay, so here's k. This is the important part. K, n times n plus 1, n times n plus 1 over 2. K squared, n times n plus 1 times 2n plus 1 over 6. And we did the k cubed right here, which is this formula, n times n plus 1 over 2 squared. Alright. Here's one with, I'm going to go fairly quick. Okay, I have 2 minutes. Here's a summation with a constant times k. We've got rules for both. Remember we talked about we can pull that constant out in front. Remember how right here, we can take that constant and pull it out front. 3, and we've got the formula for just k, which is n times n plus 1 over 2. Well, we're going from 1 to 5, so 5 is n. 5 times 5 plus 1 over 2 equals, and we've got this 3. So 3 times, this ends up being 15 equals 45. All right, now we've got a cubed. Remember our formula for cubed is down here. N times n plus 1 divided by 2, but all that's squared. Okay, we're summing up the first 10 terms. But this is a cube plus 1, so that's a constant. So remember, we're adding things. This is this one here, where if we're adding sequences, we can take the sum of each sequence. So let's take the sum of this sequence, add it to the sum of this sequence, okay? So let's add up this sequence here, which is k cubed plus the sequence, which is a constant. For this one here, we use our formula, n times n plus 1 divided by 2 squared, so 10, 10 plus 1, and then we're adding it to this, all right? Which is right here, this summing up the first 10 terms, which are 1 plus 1 plus 1, okay? All right, this is a lot. I'm not going to go in. There's a couple more examples. This is, again, we're going to break up each of these terms into sigma of k squared, sigma of a constant times k, and sigma of a constant. Here's all the rules we've talked about. But this is kind of an introduction. It's a lot to cover. All right, so that's all. That's about all I have. So, all right.